Hello, everyone, and welcome to today's webinar, Automate Testing of Your SCADA Gateway, Data Concentrator, or Protocol Converter. My name is Beth Capellas, and I'm the Marketing Manager here at Triangle Microworks. Before we get started, I'd like to go over some housekeeping items and some introductions. The webinar is scheduled to be 1 hour long. We will be stopping for questions a couple of times throughout the webinar, and we'll stay on afterwards to answer as many questions as possible. The audience is on mute, so please submit your questions online using the webinar tool under the section titled Questions. We will be answering questions online during the webinar, as well as reading and answering questions during the breaks and at the end. Next, I'd like to introduce the folks you'll be hearing from today. I'll start with our panel of experts who will be answering your questions online. We have with us Dave Gaukenauer. Dave is our Senior Developer for Distributed Test Manager, also known as DTM. This will be one of the main tools you'll be seeing here today. We also have with us Greg Godolevsky, Engineering Manager here at Triangle. And last but certainly not least, we have with us Eric Fabreau, one of our lead QA testers who works mainly on our SCADA data gateway. Next, I'd like to introduce our speakers. So our first speaker is Jackson Moore. Jackson recently joined Triangle Microworks as an application engineer. Prior to joining Triangle Microworks, Jackson spent 5 years as a microgrid system engineer, where he designed and developed load management control systems for multi-source microgrids ranging from 1 megawatt to 30 megawatts. We also have with us Matt Green. Matt is a senior application engineer here at Triangle Microworks. He's been with us for over 8 years and specializes in QA testing with all our simulation tools in Gateway. Matt is also one of our lead product trainers and presenters for webinars and customer demos. So now that you know everyone, I'd like to give you a little bit of background on Triangle Microworks before we get started. We were established in 1994 and are headquartered in Raleigh, North Carolina. We have customers in over 70 countries and work mostly with equipment manufacturers, electric utilities, and system integrators. The products we offer all support the standard SCADA protocols and fall into 3 categories. First category is source code libraries. We license source code directly to manufacturers for use in their devices and systems. This allows for a much faster time to market and greatly reduces their costs and development time. We also provide testing tools supporting these libraries and protocols. These tools are used for communication testing in the lab or the field. They are designed to troubleshoot, to simulate, and to automate testing. Lastly, we also provide a SCADA data gateway supported on both Linux and Windows for protocol translation and data concentration with standard SCADA protocols as well as OPC. Now that you know a little bit more about Triangle, I would like to go ahead and hand it over to Jackson, who's going to get started with the topic that we're here to learn more about. So Jackson, I'll go ahead and make you organizer, and you now have the screen.
Thank you, Beth. All right. Thank you, Beth. As mentioned, my name is Jackson Moore, and I'm an application engineer here at Triangle Microworks. In a short time, my fellow application engineer, Matt, will be leading us through a demonstration of our new automated gateway test manager. But before we get into that, I want to provide us with a little background on what the gateway test manager is and why we are so excited to be showing it to you today. Let's start by taking a moment to establish some common terminology. Specifically, I want to share what we here at Triangle mean when we use the term gateway. In a broad sense, when we refer to a gateway, we mean a device which collects data streams from various other devices, speaking various communication protocols, consolidates those data streams, and passes on a new combined data stream. Data concentrators perform much of the same functionality, but usually without the emphasis on support for multiple protocols. In much the same way, protocol converters also overlap with our definition of a gateway, but generally without the emphasis on support for multiple devices and data remapping. But in the end, much of the distinction boils down to semantics, and although we will be using the term gateway today, I think it's best for us to think of it as an umbrella term, as our discussions are really applicable to devices of all three types. So now that we've established some common terminology, let's take a look at a scenario where a gateway might be used. In the image to the left, we have a network diagram depicting a simplified version of a common network topology. Starting from the bottom of the diagram, we see three generic end devices, which in this case communicate using three different protocols. Data streams from each of these devices pass into the gateway, where they are remapped and converted, and then passed on to the SCADA system and historian at the top of the diagram. In much the same way, data might flow in the opposite direction, with control signals originating from our SCADA system at the top being passed through the gateway before being dispersed to our end devices at the bottom of the diagram. So now that we've established what it is that a gateway does, let's discuss how a gateway is configured. Following the principles of any engineering design process worth its salt, before you jump in and begin configuring a gateway, you must first decide what its function will be. In the case of a gateway, this means defining what data will flow in and what data will flow out. This information is captured in a document, commonly referred to as a data map, and typically looks similar to the figure on the left. Commonly in a spreadsheet style format, gateway data maps specify a device name, protocol, and data address necessary for each incoming and outgoing data point connection. In some cases, scaling factors and other metadata may be present as well. In large SCADA systems, it is not uncommon for there to be hundreds of devices, each with thousands of data points. Before gateway configuration can begin, these connections must be defined in a gateway data map. After intended gateway functionality is defined, it is ultimately the role of the SCADA engineer using the data map as a blueprint to configure the gateway. And believe me, I speak from experience when I say this is a tedious task, error-prone, and not for the faint of heart. So given what we know about this error-prone manual task of gateway configuration, how do we verify that the configured gateway behaves as described in the gateway data map? The answer is you test it. Traditionally, gateway validation testing has been performed manually and requires all hardware to be present. This means the end devices and SCADA systems that you see in the diagram to the left must be configured, powered up, and present on the same network as the gateway before testing can begin. Because all physical hardware is rarely present and connected in the same physical location prior to final commissioning, traditional gateway validation testing may only be completed at the end of the engineering process. The common approach to validation testing is for an engineer to connect to each end device individually, manipulate a specific data point, check to see if the manipulated data makes it through the gateway to the SCADA system, and then rinse and repeat. Given the size and complexity of modern SCADA systems, thorough gateway validation testing can be incredibly time-consuming. Additionally, manual processes such as this are notoriously prone to error, and any late changes to the gateway might mean that validation testing needs to be repeated. All of this has led to Triangle Microworks seeing the need for a better solution. And today we're excited to be introducing that solution. The Gateway Test Manager, a module within our flagship test and simulation tool, Distributed Test Manager, or DTM. As those of you who have used the tool will be aware, DTM allows for accurate communication simulation of each device within your industrial network. This includes both clients and servers in a range of common protocols, including DNP3, IEC 61850, TASE2, Modbus, and more. However, new to this release is your Gateway Test Manager, which enables the quick and easy specification of thousands of point-to-point tests between those simulated devices, all with your gateway placed right in the middle. Perform simple point A to point B mapping checks. Perform complex tests of quality, flags, class, and other protocol-specific metadata. Check how your data arrived, be it polled or unsolicited, and make sure it arrives within the time frame that you specify. You can even test SCADA controls being passed down to end devices. And best of all, this can all be accomplished with no scripting required, thanks to our newly introduced actions testing concept. But before we dig into actions, let's take a look at a simple test plan and see how it works. Here we have two figures which serve to illustrate a series of basic tests. Starting on the right, we have a simplified test plan where each row represents a single test, or more specifically, each row represents a single test of an action. The particular action specified here, named monitor data point, checks to see if the gateway has a mapped connection between a source and destination data point. On the left side of the slide, we see our end devices, which are being simulated in DTM. In the middle, our gateway, the physical device whose configuration and performance is being tested. And on the right, our SCADA system, which is also simulated in DTM. As we begin execution of our test plan, the Gateway Test Manager will check each connection individually, as stipulated by our chosen action. A known value is placed in the source register of the simulated end devices. In order to pass the test, the gateway must map this value through, providing it to the designated destination register in the simulated SCADA system, which is being monitored by the Gateway Test Manager. This process is completed for each row or test within the test plan. Now, before we move on and take a closer look at actions, I do want to take a moment to highlight something. You may have noticed that our test plan, the table on the right, looks similar to the gateway data map from earlier. You will recall that this was the definition document used to configure the gateway. This similarity is not accidental. In fact, the Gateway Test Manager was designed from the ground up with your existing data maps in mind. And while there are several methods for creating a test plan, all of which Matt will be demonstrating shortly, I hope you will pay special attention to our data map import feature, as it is one that we are particularly proud of. But before we get to that, let's take a closer look at exactly what an action is and how you will be using them. The first step to building a test plan is deciding what you want to test. In the Gateway Test Manager, this means choosing which actions you will be using. The example test plan we just looked at used several instances of the monitor data point action. This is a high-level protocol abstracted action with relatively few inputs. However, we also provide protocol-specific actions, which allow for more granular testing and in turn, more specific results. So let's take a look at one of those. Read analog input class is an action specific to the DNP3 protocol. Like the generic monitor data point, this action will perform a source to destination value mapping test, specifically on a data point of the type analog input. However, unlike the more broad action that we used before, this action allows for testing of features and metadata specific to this protocol and data type. For example, class, quality, flags, and timestamps can all be tested with this action. To achieve these more detailed test results, we will require a few extra inputs. For example, if we want to check a data point has a specific expected quality when it arrives at its destination, we will need to provide that expected quality as an input. These inputs are generally optional, and details of action behavior is covered in our companion documentation. While we have only looked at a few example actions included within the Gateway Test Manager are a host of similar protocol-specific actions for use in detailed testing applications, with more and more being added in the future. And finally, we do offer the ability for users to customize existing actions and even create their own. Written in JavaScript, And with access to the entire DTM function library, users have the option to not only tweak and customize our included actions, but also to build entirely new and powerful actions unique to their application. And by no means do we see applications limited to gateway testing. And now, before we get to our hands-on demonstration, let's take a brief pause to answer any questions that you might have.
Okay, we did get a couple of questions in. The first question, what protocols are supported in this test manager?
So on day one, we will support 61850 and DNP3. And in the near future, we'll be adding support for every protocol within our DTM library.
Which, just to follow on, would include 6870-5, Modbus, and ICCP. Next question, can an RTAC be tested in this way?
Absolutely. An RTAC is an example of a data concentrator, and it could absolutely be tested in this way.
Okay. Another question we've got here, who writes the actions for the action-based tests?
So provided out of the box are a host of actions specific to protocols, as well as more general ones which you can choose depending on how detailed your tests need to be. And then we do provide the ability for you to create your own custom actions afterwards, should you need to. And we are available for support if you need help with that.
Okay, I think what I'm going to do is switch it over to Matt now to start the hands-on demo portion of it. We do still have questions coming in, so please feel free to continue to submit those. You'll start to see answers from the online panel. So we will get to those questions. With that, Matt, I'm going to go ahead and make you presenter. And you should have the screen.
Thanks, Beth. Thanks, Jackson. So today we're going to be looking at DTM and our new action-based automated testing for gateways. But the first thing we need to do is get familiar with DTM and its environment. So let's take a look at that to start with. On the left-hand side here, we have what we call the workspace pane. This is effectively where you can put all of the things that build up your simulated environment. You can add folders to organize things. You can add in devices such as this 61850 bay controller device or this DNP3 outstation. You can add in our testing nodes. So I've pre-made one of these today that I've just named automated testing. You can also add in things like auto data changes, JavaScripts, different sort of GUI displays. Basically anything that needs to build up your environment and your testing scenarios can be put here in this workspace. I also want to take a look at this testing node here. This is effectively going to be how you're going to be interacting with this new testing way for testing gateways. In the middle here, you have all of the tests that you'll be running, a description, an optional description of what that test is and what it's going to be testing. And then if the test is run, we'll have a log down here of what happened during the testing. We have a few options over here, including managing the tests and managing the actions that we'll be using during these testing, and of course, a way to export the results that you have. At the bottom left here, I have our outstations and our 61850 servers model. So currently I have here the 61850 bay controller model that we have, and that's just based on the ICD file used to create this device. And I know specifically we'll be looking at the breaker position that this device is monitoring. So I'll go into the XCBR, into the pause, and then keep an eye on that STVal. Likewise, we have our DNP3 outstation. Its database is shown right here. So effectively, I'm going to have all of our downstream devices on this left side. And then on the right side here, I know that our SCADA data gateway is presenting its database to us as a DNP3 outstation or a database. So I went ahead and created our SCADA master as an MDNP, and I'm showing its database here. Speaking of which, we won't be looking at it too much today, but this is our SCADA data gateway application. As Beth mentioned, this runs on Linux and on our Windows, and it will be working as our data concentrator and data translator today, and it will be our device under test. So now that you see how the layout of DTM is, let's take a look at how you'd create something like this. So effectively what we're going to do is we're going to try to create this scenario. We've got our SCADA data gateway here in the middle, and that's our device under test. And we need to simulate all of the inputs and all of the outputs into our gateway. So down in DTM and the downstream devices, we have X number of downstream devices. In this situation, we just have 2, but that could obviously be scaled up. And we also have our SCADA master that we need to simulate. So how would we go about actually creating this environment for our SCADA data gateway? Well, the first thing we can do is add these downstream devices. So to do that, you would just go to any node, like a folder or just a workspace node, and do a right-click, manage, add, and we'll look at DNP3 first. DNP3 outstation. That'll pop up a configuration window, and it will walk you through it similar to a wizard. So the first tab here is going to ask you where you want this device to be simulated on and what hardware is it going to use. So DTM stands for Distributed Test Manager. The distributed in that means that you can actually distribute the simulation across multiple machines. For the sake of this demo, I only have the one ThinkPad, so that's obviously where I'm going to host this device, and we could give it a name. The channel tab is where we're going to be putting in TCP/IP or serial information. That includes your local address, your remote address, ports, things along those lines. By default, what we've done is we've put in the most generic information, the most open information we can. So 0.0.0.0 means basically use any of the IP address that my network adapter allows. And the remote address star means accept a connection from pretty much anyone. It's not specifying the IP address that my SCADA data gateway is sitting at. It's basically saying if there is a master DNP3 out there that wants to connect to me, go ahead and let it. And then of course, for DNP3, the default port is port 20,000. Being as this is a simulator tool, all of this is configurable though, so you can go to whatever port number you'd like. You can choose any IP address that you'd like. You can set the remote IP address. You can even come in here and type in whatever IP address that your gateway is expecting you to be communicating on and actually assign that IP address to your adapter. Now note that your network adapter can have as many IP addresses as you want to add to it, but we are actually inside of DTM going in and reconfiguring your network adapter. So if you're trying to simulate a piece of hardware sitting on your desk right next to you and you're using the exact same IP address as it, make sure that you're on a testing network or maybe you switch off the other device, or else you might get IP conflicts and it can cause all sorts of errors. The session tab here is filled with things specific to this protocol. So in this case, we're talking about like the link layer addressing, which we put 4 and 3 in, whether unsolicited messages will be supported, and secure authentication. There is also the database here. By default, we've just kind of put 40 of everything in there. This allows you to kind of play around with it when you're first using DTM. But when you're wanting to simulate a specific device, we recommend that you reset the database and say, I don't know, I want 41 binary inputs, and maybe I want some analog inputs. I want, let's say, 12 of them, right? You can build up your database however you would like. And then you can also go in and configure these points even further for things like where should this data show up in? So is it a class 1, class 2, class 3? What sort of variations do you have? It's all absolutely configurable. And then the last tab here is the advanced tab. This is where you're going to go and find maybe the 10-15% of the stuff that you're not going to be using super frequently. So if you're going to be simulating a device and you need to do it down to its frame sizes and buffer sizes and timeouts, you can dig into the advanced and find any of these parameters in here. And then just because it's here and we've gone through the rest of them, let's take a look at multiple devices. Basically, when I click create multiple outstations here, it's going to take the configuration of all the previous tabs and put it into this table. And then I can increase and decrease as much as I'd like to create more or less of these devices. Of course, we can't have all of these devices sitting on the same IP and port, So we have incremented the port here, but this is all editable. So you could come in here and change the IP addresses to something else or whatever you'd like to do. So that's a way that you can kind of quickly bring up these devices. So I'm gonna go ahead and cancel this because I already have my device out here. The second thing we're gonna look at is 61850. So I'm gonna right click, manage, add 61850 server. You'll notice that a lot of the tabs here are actually not needed for 61850. And that's because 61850 supports a configuration file called an SCL file. It's ICD, SCD, anything along those lines. So you can actually go and pick that file. You can go to your import configuration. That'll just bring up a Windows Explorer that you can move through and find your file. Or if you've already imported it into DTM, you can just select it and hit OK. And that will go and configure this device to match exactly what is inside that ICD file. Of course, because it is a simulator tool and we want you to be able to have flexibility when it comes to your simulation, you can go back and make changes to it. But by default, we've already filled all this out for you. And just like before, we do have an advanced tab for the settings that you may need to go in and make small tweaks to if you're trying to replicate exact frame sizes or things like that. So that's how we're gonna go ahead and simulate all of our downstream devices. Let's take a look at our SCADA master. Our SCADA master here is simply just an MDNP. So I would go through the same process as before. So I could right click, manage, add DNP3 master. And then you'll notice this is exactly like the outstation configuration. It's also gonna be similar to our 101, 104, Modbus. All of those things are gonna have the exact same layout. So you've got where do you want the device, what's the connection information, we've got our link layer addressing. There are a few things that are slightly changed because this is a master and not an outstation. So we've got some extra parameters here that you can interact with. But all in all, it's kind of the same process. Once you learn to do it one way, you should be able to do it with most of our other protocols. Now, the next thing that we're going to want to do is find a way to get the data from the SCADA data gateway into DTM, because we can obviously change the data in the downstream devices, but we need to be able to verify that with the upstream devices. So I'm going to drill down in here and show that I have unsolicited messages and an integrity data poll here. Those are just a few of our options. And to add those, you would do a right click, commands, and then you've got all of the different commands and controls that this device can send. So for example, I have the integrity data poll here, but you can also do unsolicited messages as well. So I just brought up the unsolicited messages, and what we can see here is we can check the event data classes that you're interested in, and then you can obviously enable or disable it depending on what this control is going to do. Another thing that might be interesting when doing this is this scheduler down here. So for things like enabling unsolicited messages, if you clicked on connect, that means the first time that this master connects up to our SCADA data gateway or any DNP device for that matter, it'll automatically enable unsolicited messages. So you're already going to start getting these this event data into your device. Whereas periodically wouldn't make too much sense for unsolicited messages, it would make a lot more sense for things like the integrity data poll. So you can set this up to do an integrity data poll every 24 hours, every few hours, every minute, down to the seconds, depending on what you need. So we've kind of made it so you don't have to go in and manually interact with these controls and commands. You can actually set them up on a schedule and have them happen automatically. So now we've talked about how to add controls, how to add the SCADA master and all the downstream devices. Let's take a look at how to add a testing node here. So I've already created this automated testing node, but I figure we should start from scratch and I can show you exactly how we could build something like this up. So again, you just go and you right click, manage, add, test manager, gateway test actions. I'm gonna give it a name and then hit OK. So now we've got a blank one of these. And what this will allow us to do is build up our tests from scratch. So let's assume that we are just going to do everything within DTM and we're going to build this up just right away. The first thing you're going to do is go to manage tests because we have no tests here. And it's going to give us a screen that looks like this. So what we're going to do is we're going to add a new item. I'm going to go ahead and monitor a data point, and that's the test action I'm going to be performing. And then I'm going to get a little bit more real estate here so we can see this without having to scroll around a lot. So the test name is going to be breaker on Okay, so I'm gonna go ahead and interact with this breaker position here. Now I could go through and click through and type in each of these things, but since we already have the source of where the data is coming from and the destination of where it should end up, we can actually just grab the value and just drag it in. And it'll go ahead and format it for you for what's necessary. For 61850, you only need path 1 and path 2. So we'll look at the destination now. I know, or maybe I have a table next to me or a file open somewhere on my computer, that this breaker position maps to my binary input 0. So I can take that value and drag that up to my destination, and it'll go ahead and format that as well. So we're turning the breaker on, so into the on position. So the set value, I'll just put on in here. Await, I'll come in here and say, I don't know, 20 seconds, 220,000 milliseconds. The initial value, so the initial value will allow you to set up the initial conditions of your test. So effectively what you can do is if you're setting the value to on, but it's already on, that may not generate a report. It may not actually send that data across. So we'll set up the initial value of off, and then the expected value, well, we're turning it to on, so we'd expect the binary input 0 to also be seen as on. We also have some sections here for quality. I won't be touching on quality too much today, so I'll actually be leaving these blank. What happens when you leave a parameter blank in this test manager is it goes ahead and it tries to assume kind of the nominal state for you. So when it comes to quality, if we leave it blank, it's going to assume the data is valid and good, and then its expected quality on the receiving end also should be, valid and good. Likewise, we can do that with a few other fields. So let me show you how that would be done. I'm going to add another test here. I'll do breaker off. Again, this is going to be the same 6150 point, so I'll just drag that over. Because it's the same point, it's getting mapped to the same place, I'll drag that over. The value I want to set to off. And the weight, I'll do 20,000 again. But for this situation, I'm going to leave the initial value blank. I'm going to say I don't really care what my initial conditions are for this. I can leave the expected value blank as well, because DTM can assume, well, if you're setting the value to off, I'm going to go ahead and assume it should be the equivalent value in whatever protocol you're mapping to. And again, I'll leave these blank as well. And then just to show I can do it, I'll make a third one here. And I'm going to do DNP. I know that my binary input 0 on my DNP device is going to get mapped to the binary input 1 on my in device. So I'll put those there. I need to give it a name, so I'll say this is DNP 3 on P0, right? So I'm going to take P0 in my DNP device and I'm going to set it to on. And again, I'll set this to on, but the rest of the stuff I can pretty much leave blank as it will make an assumption. So now I've gone ahead and configured these devices or these tests. So if I just hit OK here, we'll see that those 3 tests then do show up. So I can come into here and just double click on this test. It'll go ahead and let's look at the log here. It went ahead and set the value to on, and sure enough, my downstream device did set to on. It was waiting for a change in my SCADA master. That value came across as on. It took a little over a second, and so the test passed. So I can come in here and see any sort of output messages and informational data as necessary. Again, I can come in and run the second one. We can get that value to go off. We can see the value come across as off, et cetera, et cetera. So that's how you can go ahead and just kind of manually create up these tests, and that'll allow you to kind of jump into DTM and get your test up and running. Now, the question then comes in about how you can expand these, right? So let's go back into manage tests here, and I've got these 3 tests still configured here. Well, what you can do is export this to a CSV file, and I'll export it to this custom gateway test. I'll go ahead and replace it, yep. And then I'm just gonna go to that and open it up. So this should look very familiar as to what we were looking at before, but now it's kind of in the Excel format, right? which gives us all the power that Excel already has to increase our test coverage. So I can just highlight this one row here and then drag it down and get a whole new test, right? I've got another monitor data point. This one's on P1, the same value. If we're gonna move it to P1, I need to change this to actually be P1 instead of just P0 again. The destination path is probably gonna change because I know the mapping is different there. And Excel does what Excel does. It did try to increment the wait time as well. Would 1 extra millisecond really make a difference? Not really. So now I've added an additional test, but you can use all the powers of Excel to do this however you want. So you can use equations, you can use any sort of formatting you're comfortable with. Basically, as confident you are with Excel, you can use any of that stuff to try to make your own tests. So for example, I know my gateway follows the same pattern where each of P1 maps to P2 in our gateway, SCADA data gateway application. So, and then so forth, P2 maps to P3, et cetera, et cetera. So I can actually just highlight this as a pattern and then just drag it, as far down as I really want to. And now I've created a bunch of new tests. So if I come in here, save this off, and then I'm gonna import that CSV file and import the same one that we were just working on. Well, now I have 30 some odd tests, right? So if I hit OK now, it'll go through and it will populate my testing in here. And then I can just come in here and double click on my tests and it will run through and actually start running some of these tests. So I can just run them one by one. I can multi-select them and then say run selected tests, or I could come in here and do like a run of all the tests. This will allow me to go get a cup of coffee or take a walk down the hall, talk to a coworker. Heck, you could even set this up to run as like a nightly thing where you just come in and all these tests are already run for you. It's also worth noting that after you make all these changes and after you run these tests, you can then export the results out so you can have kind of a log of what's been done yesterday, what's being done today, what's hoping to be fixed in the future, what things have been improved, and what things have regressed. So you can export all this results as XML, CSV, HTML, and just as a simple text file as well. So we have that there so you can, every time you hit reset test results, you don't have to feel like you're losing your progress. You have all that stuff saved off as well. So this is where we're going to come and take another small break. We're going to do another Q&A section and see if there's any other questions coming up about DTM or potentially even the slides. So I will pass this back over to Beth for a second.
Okay, thanks, Matt. Yep, we do have a bunch of questions coming in. So let me start from the top here. Normally, do you have to test again on the field after installation of devices?
Good practice says that you probably should test. So you can obviously test in a testing environment when you're doing things like this with the with your gateway, and that'll make sure a few things. If you're doing it in a simulated environment, you can, number one, make sure that the device is able to do all the functionality that you need. So if you need specific class reads or if you need specific timings, you can do all this in a simulated environment. Number two, what you'd want to do is verify that the actual mapping has been done. I think Jackson mentioned earlier, it's a fairly manual process to go in and map all these points across, and it can be really easy to accidentally put the wrong point in or the wrong destination point or something like that. So you might get values going to the wrong place. So in the simulated environment, you can verify all that's done too. Once you've done that all in the simulated environment, you've confirmed that the behavior, it works, the functionality is there, and that your configuration is proper. When you go and put it into a physical environment, you can already weed all of those out as potential issues if you do run into issues in a real environment. So it could be a wire crisscross, or it could be something not turned on, or maybe a device isn't generating the reports you expected. You can start to look at outside of devices because you can be very confident that your gateway is performing properly.
Okay, great. Next question. Is it possible to have simulated devices, for example, a Modbus slave with a physical Modbus master?
Oh yeah, 100%. So anything in our simulator tool here in DTM and pretty much all of our applications are acting as if they were real world devices. So when we plug a SCADA data gateway or any sort of gateway, data concentrator, things like that, into our simulated environment. As far as it's concerned, all of the upstream and the downstream devices are physical devices. Likewise, if you just have a Modbus master or DNP master or whatever, if it hooks up to a simulated outstation slave server, whatever it is inside of DTM, as far as it's concerned, it is an actual physical device, and you can test that just as easily.
Okay, next question. How many IEDs are supported and recommended with the gateway?
Inside of our gateway. So our gateway is highly configurable. You can connect up to as many different devices as you need to in order to use it as its data translator or data concentrator, or however you need to use it. You know, so, and in DTM, we support, you know, as many devices as you really need to run your simulation. It's all configurable when you like pick up a license or something like that. So if you only need tens of devices, then we can configure it to be like that. If you need hundreds, we can run it as well. Some of our really big powerhouse users can even simulate thousands of devices, but that's also where kind of the distributed nature comes in. If you start to need more devices than a single computer can handle, you can actually use the resources, the RAM, the CPU of additional computers with no extra cost, no extra license requirements or anything like that. You can have as many computers inside of that environment as you need to simulate your devices.
Okay, and just with keeping an eye on time, let's go ahead and go back to the demo. Certainly keep asking your questions online. We'll continue to answer them, and we'll have some time in the end as well. So I'll shift it back to you, Matt.
Perfect. So we really haven't touched on the action types today, and I definitely want to do that. So far, we've really only been using the generic point-to-point tests, and that's been good enough to show off the base functionality of this feature. We've also created and used a CSV file that was built off of a seed exported by DTM. But the question is what if you already have a gateway engineering CSV file and you would like to use yours? This is where we can start to take a look under the hood, and we can go over here to manage actions. So this is what we've been running off, which is just the default for DTM right now. And I'm gonna go ahead and reset this and show you how you can build this up manually. So the first thing we're gonna look at is we're gonna look at, again, the actions we're already familiar with. So I'm gonna go and add just a gateway action here. This will allow you to bring in the whole library of gateway actions, or potentially just make a custom one based off of one. So I'll go in and say, okay, this is the monitor data point test that we've been already familiar with, so I'll bring that in. And you could give it a custom name or whatever you want to do. So if I hit OK, that'll bring in the monitor data point test as an action into our testing environment here. So if I click on this, you'll see all of the things that I have been looking at in the other windows as kind of parameters here. So we've got our test name, our source, our destination paths, the initial values, anything along those lines is brought in there. So these are the generic monitor and control data point actions can be used to determine if a mapping of a gateway is correct. It doesn't really consider the method in which the data is moved through the gateway, like polling or reporting. It's also really convenient because you can use these two actions and work across multiple protocols, as I showed off with the 61850 to DNP3. The simple functions we're looking at right now are likely to be used by the integrators who are trying to validate mapping of their configuration, and that's the main point of their testing. There's also a bunch of other libraries in here we can take a look at. So let's look at DNP3. So I'm gonna go ahead and just bring in the whole library of these just so you can see what it would entail. So all of these were part of the DNP specific library. These are more likely to be used when not only mapping and configuration needs to be verified, but they'll also allow you to have tests for more specific requirements. They can be used to determine if the behavior of your gateway is correct as well. They support a more detailed version of testing of quality and timestamps and allow you to specify acceptable ranges and acceptable qualities coming in from your data. They also allow you greater control on how the protocol requests and commands are formed. These functions are likely to be used by OEM vendors to verify equipment behavior or to perform regression tests. They can also be used by integrators in cases where more specific tests are required and more detailed investigation needs to be done. So for example, I have this read AI class, so read analog input class, and you're gonna see a lot of the parameters here kind of similar. We've got our source path, we've got our destination paths, we got our set values, Our read delay is basically how long are we going to wait. But what you will notice here is we've got some other things like class. So if you're reading a analog input class and you want to make sure that that data that you're looking for is part of the correct class, you would need to specify which class you actually want to read. And you can actually see a brief description of what each of these parameters here is on the right. You also might have your flags for quality. And then another thing that you might look at is especially because we're looking at an analog value here, is this delta value or this deviation value. So let's say your downstream device is dealing with an analog and it's recording like a 10.5 or something, right? But you know that your in device, your SCADA master, it only deals in integers. Well, you're never going to get a 10.5 in an integer. So this deval here, this delta, allows you to configure a number of, if it's within a certain range. If you sent 10.5 and I got 10, that's acceptable. If you sent 10.5 and I get 11, is that acceptable? So you can put 1 in there to allow a full range of 1, or 0.5 if you're trying to just do some sort of rounding. So you can watch for that. In a likewise way, we can do that with a timestamp. So very rarely do values get translated and converted and then moved through a gateway and have 100% precision on your timestamp. You might be a few milliseconds off. It might be in a different format. There might be some changes there. So what's the differential you're allowing to be different from the time the event occurred on the downstream device and the time that is received by the gateway, by the gateway, and then mapped up to your SCADA master. So you can fill that information out as well. I'm going to go back to our monitor data point action here, and I'm going to show you how you can bring in your CSV file used to configure your gateway into DTM and start automating those tests right away. So the first thing you're going to need is you're going to need a file like this. This is our SCADA data gateway mapping. So let me go ahead and open this guy up. We've got obviously the company that made the SCADA data, it's us, the time that these tests were created or this file was created. We've got a purpose of what each of these rows are, and we have some of our other information in here. So this is a file that we can use to help us verify and to set up the mapping inside of our SCADA data gateway, so you can look and figure out which points should be mapped to which points. So let me go ahead and close this. And I'm going to go ahead and import. And I'm going to go to our SCADA data gateway mapping, double click on that. And sure enough, we'll start to see some of our column headers coming in here. So what this will allow us to do is start to map these things over. So test name is not required, but I have purpose, so that'll be good enough. The source path, that's my device name that's going to be connected with my external IDs. The destination, that's my SCADA device. SCADA type, SCADA point. Initial value is ival. Set value is value. Now it is worth noting, if your CSV file may not have all of these points, you can come in here and just right click and add. So if I didn't have value in here or something, I could just right click and add and then type in value and drag that over. And then we can use all of the abilities that we've used previously to build up our tests before. So we can use manual input or the CSV file method or whatever. Expected value is operation results. Quality time, there's a wait. I'll go ahead and drag the time over here. And then I'll hit OK. So what that'll do is it'll change what we actually have access to when we go into manage tests. And now when I import, I can import that same SCADA data gateway mapping file. And it'll automatically propagate all of the values into the defined places that I've drag and dropped them. The only thing I didn't have inside of my SCADA data gateway was this concept of test actions, because it wasn't necessarily set up for that. Luckily, I can just click at the top, scroll to the bottom, and then do a mass select, and I'll just do the monitor data point. Apply those, and then hit OK. And what that's going to do is it's going to go and it's going to redefine all of our tests. So now instead of having 2, 3, 10, I think we have 100 tests now set up to be able to run. So I can come in here and run these values and be able to see, yes, the position of the breaker again was changed to on. There was an event. It took 1.1 seconds to get across. So Today we've looked at a bunch of different passing tests. Let's take a look at what would happen and how this tool can help you find things that fail. So I'm gonna go ahead and run this test here. And what this is in this test, I'm gonna go ahead and let's say I made a mistake inside of my gateway. And what I've done is I forgot a knot, or I changed a value came in as true and I accidentally put a knot in there, or I should have converted or whatever. The value just came through and it's not what I expected. So we obviously failed the test. The values did not match. It expected a false, it received a true. So that lets me know I need to go look at my gateway and see if someone put a wrong equation in there or some sort of mapping. This next test I'm going to run is going to be something that in the gateway I just completely forgot to map. I mapped it maybe to the wrong point, or I just didn't map this point at all. Effectively, what it's going to do is it's going to change this value downstream, and then it's going to wait for it in my SCADA master to show up, and it's never going to show up. So if you see something that says timeout waiting for point to change, that means that the point never changed. It didn't get the wrong value, it just didn't get any value at all. So you want to go look to make sure your mapping is valid there. The third thing that we're looking at today is at an analog value. So on my downstream devices, it's monitoring, say, a voltage or something, and it's reading 22K, so 22 kilovolts. So what's going to happen is I'm going to expect my gateway to have scaled that up, so that way when my SCADA side, I can look at it and just see the 22,000. Well, sure enough, I forgot to do my scaling. The values obviously didn't match again. It expected 22,000, but I only got 22, so I can quickly see, oh, I forgot to put my scaling factor in there, and I can go and fix that. So at this point, I'm just going to go ahead and run all of our tests and just kind of run through this process here and let you see how this looks as it goes. But to summarize, today we have defined what a gateway is, how it's configured, and most importantly, how it's tested. We've shown that testing gateways, data concentrators, and the like can be largely automated. We've discussed how complicated that these data mapping files can be and how prone to user error testing may be when performed manually. Using DTM, we've demonstrated the ability to simulate both upstream and downstream devices, as well as our new Gateway Test Manager. With this new automated action-based testing tool, you can quickly generate and execute detailed plans tailored specifically for your gateway and your existing data maps. We hope this tool will help you move beyond the traditional, error-prone, and time-consuming manual gateway testing and allow you for quicker and more accurate test results. And with that, I'm going to pass it back to you, Beth, for final thoughts and Q&A.
Okay, I'm going to take the screen back. And we'll do a quick wrap up, and we've got a lot of good questions coming in, so I am going to flip over to those questions in just a minute, so hang on for that. Okay, so just in case you did come in late or you wanted to review what you saw today, a recording of this webinar will be posted on our website. You can still also access it through GoToWebinar as well as our YouTube channel. The functionality that you saw here today will be available to try as a beta in the next 6 to 8 weeks. If you are interested in receiving a temporary DTM license to try what we've seen here today, please let us know by responding to the survey that you're going to receive directly after this webinar ends. There is a question specific to receiving a beta license. If you select yes, I will reach out to you once the beta is available and provide you a temporary license with installation instructions. And of course, if you have any other questions or would like additional information, please feel free to email sales@trianglemicroworks.com at any time. So that does conclude the presentation part of the webinar. As I've mentioned several times, we will stay online as long as we need to continue to answer questions. I do see quite a few coming in. So with that, I'm going to just flip back over to reading off some questions and opening that up to the speakers and possibly the panel. So first question, does DTM have an interface to enable running tests from another system? For example, continuous integration system.
Yeah, so we work really hard at allowing access to our manual process in DTM via scripting. So we have a Java scripting engine that we run inside of our DTM tool. And what that will allow you to do is basically set up and run different tests and test plans and things like that through JavaScript, and then we've interfaced that JavaScript to Python, to Jenkins, to all sorts of other scripting engines, to command lines. So we do have an interface to allow you to kind of do that. I know that we absolutely can do that with our test manager tool. When it comes to our gateway test actions, we should be able to leverage some of that and get that quickly. I don't know if that will be in the beta that's coming up soon, but that's something we'll definitely support, and we have in the past.
Okay, next question. How would I use actions to test higher level functionality such as interlocking?
Let me pass this one off to Dave, who is our DTM engineer. I know he's done things specifically like this in the past, so I think he'll have a better answer.
Yes, this is Dave Gokenauer. This is one of my pet topics. Basically, the actions that we've described today are typically point to point. I call them closed loop, where you've got a source and a destination, and you're changing a value in the source and then monitoring the destination. That works fine for monitored data points in a gateway or data concentrator. It also works well for control data points. We can issue control tests where you operate a control on your SCADA system, and it makes its way through the gateway and down into the remote device, which would be simulated, so we can actually intercept the control in the simulated device and make sure that the information is correct and things like that. We believe that's a very significant use case for this type of thing, is this point-to-point testing or closed loop. However, we can also build these actions to do higher level functions. For example, interlocking is a common one that is very time consuming to test. You have to basically go through every breaker in a system and make sure that the conditions are set up, and then the breaker will not operate if the interlocking conditions aren't met, and it will operate if they are not, or vice versa. I get that backwards. Anyway, the point being is all that done. So what you could easily envision is developing an action that takes multiple breakers in as on the input side, and sets up the required conditions. And then if at any point, if you run this action, it will look at all those source breakers and then watch the target breaker, the one that you're actually testing at the particular time, to make sure that it does the appropriate thing, either operates or not, depending on whether interlocking is satisfied. What we see a lot is that utilities and integrators will come up with a scheme for interlocking that could be that's common throughout their systems, or certainly a system, but usually throughout multiple systems. And what you could do is develop an action that is then applied to all of your substations, and the same action could actually be applied to all of the interlocking throughout a system, or you might have 2 or 3 different types of interlocking, things like that. I can see this actions being developed for breaker failure and protection schemes as well. These are not things that we'll have in our first release. It's interesting because frequently they're very device or very system specific. So it might be something that are developed custom based on a particular vendor, a particular integrator, and how they do things. We do plan to investigate, is there a way for us to provide a generic version, if nothing else, as a starting point for people to refine theirs. But those are really the kinds of advanced actions that you could actually test substation behavior, using the same technique. The idea, of course, that one person or a small group of people or whatever could develop these actions, and then they could be used by the entire organization to test systems, with not everybody having to know actually how to develop this action. Just like really just 1 or 2 people would actually know have to develop the action. Multiple people use it.
Okay, great. Thanks, Dave. Next question, and I'll open this to the speakers, and also, Dave, this might also be you. How are data points attributes specified for actions?
So we might need a little more information on that question, but I think the ways I showed off today was you could obviously go down to the database or the model or whatever and drag that into the test taking place, and it'll go ahead and put that value in there for you. Or if you have that predefined inside of a CSV file, when you import that CSV file, it'll populate that column, that row for you.
I'll jump in and give a little more detail, and maybe depending on how the question was worded, we struggle. look at it for a while to try to figure out what was the most generic way to specify a data point throughout DTM, again, because the idea is it's multi-protocol. So, and we're going to support multiple protocols, and we needed a generic way to support. So we've come up with a scheme that all of our actions, all the actions that Triangle develops, will typically use 3 parameters to specify a data point. And these 3 parameters are will be a little different depending on which protocol and how you're using it. But the first parameter would typically be a device name. So again, if your substation has unique device names, that works great. The first parameter could also be a DTM path, which admittedly no one's going to have in their predefined spreadsheets, but is fairly easy to generate if you need to. That would allow you to work with scenarios where you don't have unique device names in your substation. But the first parameter, for example, might be a device path. So we'll find the appropriate device. The second parameter would be protocol dependent. For 61850 or TASI2 ICCP, it will be a path, the MMS path or the 61850 path, to identify the attribute in that case. For DMP or the other protocols, the second parameter might be an object ID. So the object index, or I guess for 6870, it's the request ID that you use to identify that. Finally, for the point-based protocols like DMP and 6870 Modbus, the third parameter would be a point index. So we've come up with a scheme to identify points as flexibly as possible, with the hope that people can map this to what they're used to using and what they already have available in their spreadsheets. I will also point out that if the way we identify points doesn't work with the data you have in your spreadsheets, it's relatively easy to go in and tweak the algorithms that we use to parse these parameters so that it could parse what's available in your spreadsheets. But that would require going in and doing a little bit of JavaScript to tweak the way those points are identified.
Okay, thanks. Next question. Is it possible to monitor goose traffic?
I would assume so, Dave. There's no reason that goose traffic wouldn't be, sent from the gateway up to our master as long as we get the value. We don't really care how we got it, right?
For the most part, there's really two aspects to that question. Typically in our system, the way we can monitor goose is by simply monitoring for point changes or attribute changes. So that if suppose the goose that you want to monitor is between the outstation and the gateway, so it's on the bottom half of the diagram. One way we would look at that is we would simply see changes in the model of the device in the gateway, and we could monitor these point changes, which are a result of the goose stream, but we don't actually look at the goose message in that case. We're simply looking at kind of the results of receiving a goose message. We also have tools for monitoring the goose stream and pulling information directly from the goose stream. It is anticipated that our 61850 actions will allow you to drill down to that level at some point. They don't currently look at the goose stream to again, extract information from the stream. But as Matt pointed out, we have the capability within DTM to actually look at the goose stream, but our actions do not currently drill down and look at that. They will simply monitor for value changes, but we do anticipate doing that in the future. Sample values, I'm not so sure about. That's going to be a different challenge.
Okay. Do you offer a virtual version of the gateway for testing purposes?
So our SCADA data gateway is a software application. And so you can basically put that on a Windows machine, a Linux machine. It's supported for both of those. As for testing purposes, I think we have a trial that you can use with the gateway. And obviously you could pick up a full license of it if the trial does everything that you really need.
Mm-hmm. Yes, we do have trial versions available on our website. We also can provide license keys if you do need to work on a VM for our gateway and for DTM and really any of our tools. Okay, next question. Is it possible to send several changes of a lot of data points at the same time?
Oh yeah, absolutely. So there's two ways you could do that. If you're trying to focus more on like a load test type thing, I could recommend looking into maybe auto data changes, which will allow you to change pretty much every point that you could possibly want at the same time. and see where your performance numbers are with that. But also these test actions can be built up and made in any way you want. So if you wanted to use the gateway testing tool that we were showing off today, you could obviously have a custom action for that. And honestly, you could probably do a mixture of the two. If you really want to see how your gateway performs under stress, you could set up some auto data changes and set that up to run periodically, kind of like the commands I was showing you earlier. So maybe every 2 or 3 seconds, 10,000 points are changing, and then you could specifically monitor one point using the gateway testing tool and verify that that value did get through. Though do be a little cautious there, because you don't want the value that you're monitoring to be part of the auto data changes changing every second. You want one of them to be controlled that you can verify the value of, and the other one's auto data changing, which would just be like on, off, for 10,000, 10,001, 10,002, 10,003. So you could use pretty much any of those 3 methods to do it.
Okay, next question. Can you use external source devices, such as those with protocols not supported by DTM, with tests, such as testing an RTAC gateway and connecting physical SCL relays, since DTM cannot simulate those?
Dave, do you want to take this one too?
Sure. First of all, the point that DTM doesn't simulate SCL devices, we actually do regular. Now, we don't simulate exact behavior, but in this particular case for gateway tests, you don't need behavior. We load the model of the SCL device and we simulate it from a protocol perspective, and we can send signals, every signal in the model to the gateway. So typically, yes, we absolutely test with SCL and ABB and all kinds of other devices on both the downstream and the upstream side. We don't need to simulate the actual behavior of the device for these particular tests, because all we're doing is testing the protocol. This being said, we can replace either outstations or SCADA with hardware. The problem becomes that most of these tests, and one of the big advantages of these tests, is that they're closed loop and that DTM drives both in, so they can change the source value and then monitor the resulting value, which means it can be run totally unattended. You don't have to sit and watch them, and you can fire these things up overnight, because with tens of thousands of points, it might take 2 or 3 hours to run through all of them. So you set things up, you fire it up, and you go home and come back in the morning and see what happened. So if we're not doing closed loop where we have both sides, unless there's some way to communicate with that side, the SCADA, then we can't really tell that this has changed. Now, one of the things, and we're going to ask, I think, as a follow-up, but I'll mention it here, is on the SCADA side, we've certainly considered adding OPC support to DTM so that we can actually communicate with SCADA systems. So if you wanted to test with a gateway and the actual SCADA device and then simulated outstations, we could still do closed loop testing by monitoring the SCADA using, most SCADA systems will support OPC or something like that, and we could actually use that to monitor what's going on. On the outstation side, we've looked at ways to trigger so if you wanted to do what I call mixed mode testing, where it's partly simulated, partly hardware, we've certainly looked at ways to easily drive and control actual hardware, actual outstations. There's nothing currently supported to do that, but we could certainly do that. But again, if you want to simulate an SCL device in a gateway, and all you're looking for is protocol traffic, I want to change this attribute in the device and see it go through, we simulate SCL models all the time. Again, the clear point is, when we say simulate here, we're simulating the model and the protocol, but not necessarily the behavior. So if you wanted to plug an SCL device into your substation simulation and have it behave the way an SCL device would in the field, you would have to program the appropriate or the desired behavior into DTM using either JavaScript, or in future versions, we're going to use 61.131 to program behavior of devices. But that's kind of a different beast than what we're talking about now. That's if you want to simulate a substation's behavior, as opposed to just doing point-to-point testing of the gateway or data concentrator.
Okay, thanks, Dave. Next question. Can I configure multiple IP, and in parentheses, different IP series, for a single gateway?
Yeah, definitely. So basically, in DTM, you can add as many IP addresses as you need to run your test and connect up to your gateway. And our SCADA data gateway application will allow you to use any IP address that is already on the computer that it is running on. So you can use as many or as few IP addresses you need for both applications.
Great, thanks. Next question. When DTM acts as a master for IEC 104, in that scenario, can we see whether we can see buffered data from a physical RTU?
So you have a, so when you run as a master for 104, you'll obviously get any of the data in through the database, as you can see there. And then if you, I can't show you right now, but if you right click on that master and do show protocol analyzer, you can see all of the protocol traffic coming through. You can see pretty much everything that you would need to see, the requests and what's being sent out, what's being received, any sort of the additional information that might be stored in there as well. So you can basically see anything coming across from the slave or the controlled station to the master. You'll be able to see either in the database or in that protocol analyzer.
Thanks, Matt. And I will take this last question as a wrap up. Someone asked, will we be sharing the questions and answers in the recording of this webinar? And the answer is yes to both of that. You will automatically get a recording, a follow-up email tomorrow that will have a link to this recording. As well as I mentioned earlier, it will be posted on our website in a couple of days in our YouTube channel. In the survey that you receive, once you sign off from here, you can request to receive additional information. If you do want additional information, you will also receive a copy of all the questions that were asked here today, including ones I did not get to read, along with the answers. So as long as you select yes, please send me more information, you will get the questions and answers as well. So with that, that does conclude the question and answer session for today. I really appreciate everyone joining us today and hanging on a little bit longer for some additional Q&A session, and we hope to see you at our next webinar. Thank you, everyone.